All right, today we are talking about adding and subtracting fractions with like denominators using models. So if you look at this page, every single one of these fractions in each section has a denominator that matches the other denominator. So looking in the very first section, it says, do not, the big star next to it, do not add those denominators. We don't want to add those together. We only want to talk about the numerators. So if I look at 3/10, that looks like a heart, sorry. Okay, if I look at 3/10 and I'm using a model, then I would shade 3 of these 10 pieces. Then, if I add 4/10 to it, I'm going to continue shading. I'm using different colors so that you can see it. I'm going to continue shading, but this time I'm going to shade 4 of those 10 total pieces. So in all, whenever I combine my 2 shaded pieces together, what do I end up with? 7/10. Okay, so we are going to step 1 to figure out the algorithm for it. We add our numerators. Those are what we call the fractional parts. So in this model, I am shading fractional parts of the whole. The whole is the whole diagram, the whole strip diagram, which is 10 little squares. My numerators are fractional parts. The denominators will stay the same. We can use a model or a number line to check to make sure that we did it right. Okay. On the next one, it's subtraction. So instead of adding the numerators, this time I'm going to subtract the numerators. So 7 minus 3 is 4. The denominator will stay the same. Why do you think there's another box off to the side of it? To simplify it, which is 1/2. It could be 2/4, but then that would have to be simplified again to 1/2. Yes. Okay. So we want to make sure that we are subtracting only the numerators, not the denominators. We do not touch the denominator unless it's the very end and I've got to simplify. Okay. Now, to check this, I'm going to shade 7 of these parts. And then instead of adding more to it, it says subtract, so you could erase or cross out 3 of 8 parts. If you have an eraser on your pencil, you could use that to erase, but you could also cross out. So I'm going to use my eraser and I'm going to subtract 1, 2, 3 parts. And I can see that half of my model is shaded. But how many actual pieces are there? 4. There are 4 pieces remaining. Okay. Well, what about on a number line? What would that maybe look like? Okay, we're going to use the first problem that we did, the addition one, because it's right underneath it. So we're going to be using this problem, 3/10 and 4/10. So if I were to use a number line to help me check my answer or to visualize what is happening, then what I'm going to do is I'm going to start at 0 and I'm going to jump to 3/10. So 1, 2, 3. Okay. This is representing 3. Then I'm going to jump how many more places? 1, 2, 3, 4, right here. And then I can see that I landed at 7. So you can use a number line, you can use a strip diagram. This is right here is what we call a strip diagram. You can use those 2 things to help you visualize what's happening if you need to. Okay, so that's what we're doing next. So turn the page. You've got to understand the models, but you can also just do the standard algorithm. So we're going to do several examples with the standard algorithm. Algorithm is the steps to solving a math problem. Okay, so the math steps, step 1, step 2, step 3, those things. Okay, if I have 3/5 plus 1/5, step 1 says, if the fractions have if the fractions have the same denominator, add the what? Numerators. Very good. So in this case, 3 plus 1 is 4. Okay, step 2. Step 2 says write the numerator over the common denominator. So that is going to be 4 over the common denominator, which was 5. So my final answer will go here to complete my equation. 3/5 plus 1/5 equals 4/5. That's your standard algorithm for adding, okay? It's not any different for subtracting, except for instead of adding them together, you subtract them. Okay, so let's look at the next example. Step 1, subtract the numerators. So if I'm working with this problem here, 8/10 minus 3/10, I'm going to set up my problem so that it looks like this. All I'm going to do is focus on my numerators. So 8 minus 3 equals 5. Does the denominator change? No, it's still a 10. But don't forget to simplify. This one can be simplified. So I'm going to start with my answer, 5/10. It says both are factors of 5. So divide both of them by 5. So in order to simplify this goes back to using that GCF. GCF, greatest common factor of 5 and 10, is 5. So I would divide both of those by 5, and it simplifies to 1/2. Okay, now we just have some basic practice. Okay, we have 1/3 plus 1/3 plus 1/3. All of the denominators match. So my denominator will stay 1/3, but it's going to be 3 on top because 1 plus 1 plus 1 is 3. And this simplifies to 1. Okay? If I add in parentheses, we haven't talked about this yet, but there's something that we call order of operations. In order of operations, you always do parentheses first. Have y'all ever heard, please excuse my dear Aunt Sally, or PEMDAS or anything like that?
Yes.
You always want to do your parentheses first. This used to be in Saxon too. You've seen problems like this where you have groupings and parentheses. It's making it stand out to you. It like pops out so that you do it first. Okay, so I'm going to do 1/9 plus 1/9, which is 2/9. And then I'm going to subtract. So 5/9 minus 2/9 equals, can I simplify that?
Yes.
Yes, I can. What could I divide 3 and 9 both by?
1/3. 3.
3. So if I divided both of these by 3, it'll simplify to 1/3. Okay, what about this problem here? What do I do first?
7 minus 3.
I do 7 minus 3, which is 4/10 plus 1/10 equals 5/10. What does that simplify to? We just did it earlier. 1/2. Very good. You want to try the last 3 with your groups?
No.
Let's try the last 3 and then we'll check them together. Okay, here we go. If you look right here at the very first one, I'm going to do the parentheses first because it stands out. They are grouped together. I have to do parentheses first. So 5 minus 3 gives me 2/8 because the denominator stays the same. Then I add 1/8. So my answer here is 3/8. The bottom left, all I do is just go straight across. 4 plus 3 plus 5. So 4 plus 3 is 7 plus 5 is 12. 12/12 is equal to 1 whole. And then this one, 4, I just go left to right here. So 4 minus 2 is 2/16 plus 6/16 is 8/16, which simplifies to 1/2.